You ever notice how AI can feel like it has a severe case of amnesia? I mean, it can be brilliant one minute, write a poem, debug some code, but then the next minute, it's like it has no idea who you are. Well, a really fascinating new research paper might have just found the cure. Today, we're going to break down a system called ArcMemo, which is teaching AI not just to know things, but to actually learn from its experiences. All right, so here's our game plan. First, we're going to tackle this whole AI amnesia problem head on. Then we'll get into the two different kinds of memory that matter here. After that, we'll introduce ArcMemo itself, look at how it actually learns, see how they put it to the test, and wrap up with what this all means for the future. So let's start with this really weird paradox. We've got these large language models, LLMs, that can pull off these stunning feats of thinking. And yet, the moment you finish a conversation, their memory just gets wiped. All the little insights, the patterns, everything they figured out with you, it's just poof, gone. And that really leads to the core question, right? Humans, we learn by building on our past experiences. We see a pattern, we abstract it, and we use it somewhere new. So why can't an LLM do that? Why does it have to feel like Groundhog Day with every single problem it faces? Well, the technical bad guy here is something called the context window. The best way to think about it is as the AI's short-term memory, and it's an incredible short-term memory, for as long as you're in one conversation. But, and this is a big but, it's finite. Once that conversation ends or you feed it too much info, the old stuff gets pushed right out, and any learning that happened, gone with it. So to even begin to solve this amnesia problem, the researchers had to take a step back and ask, what does memory even mean for an AI? They figured out it's not just about storing data. There are two very different ways an AI can remember. So on the one hand, you've got what's called instance-level memory. This is basically just cramming for a test. The AI memorizes the exact problem and its exact solution. It's rigid. It doesn't help much with new stuff. But on the other hand, you have abstract memory. This is the holy grail. This is like learning the actual formula. The AI pulls out the core concept, making it this flexible, reusable tool it can use on all sorts of new problems. And this is exactly what the paper nails. We humans don't just memorize solutions, right? We build this mental toolkit of abstract ideas. You learn how gravity works once, and suddenly you understand why an apple falls and how planets stay in orbit. The goal is to give AI that same ability to generalize. So the key idea here is getting AIs to create these abstract concepts. Think of them like Lego bricks of knowledge. They're these reusable, modular ideas that have been stripped from the original problem where they were learned. And these are the real building blocks for an AI that can actually grow and learn over time. Which brings us to the hero of the story, the solution these researchers came up with. It's a framework they call ArcMemo. In a nutshell, ArcMemo is like an external brain for an LLM. It's this dedicated memory bank where the AI doesn't just dump facts. Instead, it learns to take its own problem-solving experiences and boil them down into those powerful, abstract concepts we were just talking about. The approach is just so elegant. The goal is lifelong, continuous learning. It pulls this off by storing its insights in plain English so they're easy to access and reuse. And crucially, this whole process avoids having to constantly retrain the entire model, which is crazy expensive. The result is a practical way to build a self-improving AI. Okay, so let's pop the hood and see how this actually works. How does an AI take an experience, figure out the important lesson, and then tuck it away for later? It all comes down to a really simple process of reading, writing, and learning. It's basically a three-step loop. First, you form out the memory. Each concept is structured like a little piece of software with defined inputs and outputs so they can be mixed and matched. Step 2, write. After it solves a problem, the AI reflects on what it did and summarizes the key insight. And finally, step 3, read. When a new problem comes up, it scans its library and intelligently pulls out only the most relevant concepts to help it crack the new case. The real secret sauce here is what the researchers call the program synthesis format. Instead of just saving a recipe for one dish, the AI creates a reusable cooking technique. By defining the inputs, the ingredients, and the outputs, the finished dish, it creates a modular tool it can use over and over. This whole structure forces the AI to think in a much more general, reusable way. Okay, this all sounds amazing on paper, but you know the question we're all thinking: does it actually work in the real world?
Well, the researchers put ArcMemo through a really tough test that was designed to measure exactly this kind of flexible thinking.
They used a benchmark called the Abstract Reasoning Corpus, or ARC. Now, this is not your typical trivia night. It's a series of tricky visual puzzles where the AI has to spot the underlying rule from just a couple of examples. It's designed specifically to test fluid intelligence, the ability to learn new skills on the fly, not just spit out memorized facts. It's literally the perfect challenge for a system like ArcMemo.
So, how did it do? The big headline number is a 7.5% relative performance gain. Now, I know 7.5% might not sound earth-shattering, but in the world of AI benchmarks, where researchers fight tooth and nail for fractions of a percent, a jump like this is a really big deal.
And you can see the difference right here. The baseline model on its own scored a little over 55. But when you give it the ArcMemo system, that score jumps to over 59. I mean, that's real, tangible proof that giving an AI this kind of abstract memory makes it a better problem solver. And beyond that main number, the study found other really key things. First, ArcMemo consistently beat the baseline. It wasn't just a one-time fluke. Second, they learned that the AI's ability to pick the right memory for a new problem was absolutely critical. And finally, and this might be the most exciting part, as the AI solved more puzzles and its memory grew, its performance actually got better over time. It was learning. Okay, so let's zoom out. A 7.5% performance boost on a puzzle test is great, but so what? What are the bigger implications here? Why does this really matter for the future of AI? What this research really represents is a fundamental shift. We're moving away from building these static AI models that are basically frozen in time, and we're moving towards dynamic AIs that can actually accumulate wisdom. This is a huge step towards a system that doesn't just answer your question, but actively learns and improves from every single thing it does. And as this quote from the paper really drives home, it does this in a way that's practical. The fact that this all happens without expensive weight updates, which is just a fancy way of saying the incredibly costly process of retraining the whole AI brain, means this isn't just a cool idea for a lab. It's a lightweight, efficient approach that could one day be built right into the AIs we use every day.
And that leaves us with a pretty profound question to end on. We've just seen the very first steps of an AI that doesn't forget, an AI that can build on its past to get better in the future. So if a machine can truly start learning from its own unique experiences, just like we do, you have to wonder, what will it become?